The first thing that you should always check for when you are factoring is looking for a greatest common factor. So here I only have two terms. I don't have another constant, like I don't have a +6 or +5 or something like that, either on either side of the equation that doesn't have a secant with it. I do have a secant squared, which is secant times secant, and then this term also has a secant. So that tells me that both this term and this term have a common factor of secant. So I can factor or undistribute the secant, one of those secants, not one between these two, but one out of here, one out of here. So if I factor a secant x out, because remember, secant squared x, I'll come over here, is the same thing as saying the quantity secant x squared. It's not the x that's squared, it's secant times secant, okay? If I divide this by secant x, I have a √3 plus another secant left. And then minus, and if I divide secant x by secant x, I have a 1 left over. Okay, and then at this point, I would set each one equal to 0. So secant x equals 0, √3 times secant x minus 1 equals 0. Add 1, divide by √3. This, I did not make up one that's going to work out nicely here, so you don't need to solve this because this one is actually impossible, and this one is not a special right triangle ratio. So don't worry about actually solving either of those. I just wanted to show you an example of factoring with greatest common factor. Okay, next thing before I do factoring with a leading coefficient with binomials, I want to remind you about how the variable substitution works. Okay, so here I have cosine theta that is being squared, a cosine theta that is not being squared, and then I have a constant. Okay, so here I can subtract 4 from both sides to get everything on one side. So then I'm going to have 2, move this down just a little bit, 2 cosine squared theta minus 7 cosine theta minus 4 equals 0, okay? And so now I'm looking at a squared variable term, a variable term without an exponent, and then a constant. Using a variable substitution, so picking another letter that is not really anything but theta is fine. So let's say A, okay? I can say, let's let A be cosine theta, okay? Then this becomes 2 times, so this is cosine times cosine, so that's A squared minus 7 times A minus 4 equals 0. And then I would factor this, which I'm going to remind you how to factor when we've got a leading coefficient here down at the bottom, okay? But that's how the variable substitution works. And then once you have your expression in terms of A, you solve for A, or you factor it, you solve for A, and then you put cosine theta back in for A, okay? And that's actually the same trinomial that I have down here. So after we go through factoring this, I'll go back and finish solving. Okay, so if we are factoring where we have a squared term, a linear term, meaning degree 1, and a constant, okay? So A, B, and C are all numbers, and then we have a variable squared, a variable to the first, and a constant. Okay, first thing I want to do is, draw my parentheses here, is I want to multiply the first and the last terms, okay? So A times C, I'm going to make this the product of A and C, okay? So let's do this example simultaneously. So 2 times -4, I'm going to make this a -8. Don't forget to keep this sign, okay? But I'm going to make that a -8. Now, I'm going to put AX, whatever this number is, I'm going to put that times X in both of my first spots. So I'm going to put an AX here and an AX here. So over here, A is a 2, so I'm going to put 2X times 2X. Now, 2X times 2X is not 2X squared, it's 4X squared. We have an extra 2 in there, but that extra 2 is a placeholder, and it's going to come back out at the end. So keep in mind, you multiplied by an extra 2, you're going to have to take out a 2 at the end. Also, we multiplied this -4 by 2 as well, so we've multiplied the beginning and the end by 2. You do not need to change the middle term, though, okay? All right, so now we want to look for a factor pair of this new product, okay? So factor pair of A times C, okay? And that goes into, it's not a very good arrow, that goes into these two spots, All right. And the fact that we have an AX in both of the first spots means it doesn't matter which number goes in which spot. So again, I'm looking for a factor pair of -8, which could be 1 and 8 or 2 and 4. And one of those is going to be negative, one will be positive. Okay. I need it to add up to -7. So I'm going to use -8 and +1. Again, because I have a 2 in both of the first spots, it doesn't matter which order I write these in. I could put a +1 over here and a -8 over here. It does matter which one is negative, and I want them to add up to a -7, which is why my 8 is negative. Okay, once we've filled in our factor pair in these two spots, now we are going to divide any common factor between each pair of parentheses, each binomial in parentheses. So divide by the common factor in, and really it's in either binomial. Okay, in this case, it's only going to come out of 1 because 2x plus 1 doesn't have a common factor. But remember, we multiplied by an extra 2. We need to take that 2 out. 2x minus 8 is divisible by 2. When I divide that, I get x minus 4. Notice I'm not factoring it to the front because it shouldn't have been here to start with. Okay, and then over here, I still have 2x plus 1, and that's my factored form. Okay, so let's hop back up here for a second. So this one right here, it's the same thing I have here. In terms of a, that would be a minus 4 times 2a plus 1. Okay, so just rewriting this, but in terms of a. So then I would get, just come over here, for the solving step, I set each factor equal to 0. So a minus 4 equals 0, 2a plus 1 equals 0. So I get a equals 4 and a equals -1/2 because I subtract 1 and divide by 2. But then remember that a is equal to cosine theta. That's where I go back to being in terms of my original variable theta. So I would have cosine theta equals 4 and cosine theta equals -1/2. Okay, now, once again, I made up an example that does not actually have a solution. This one does. This one would be, let's see, so it'd be a 30-degree angle in quadrant 2. So this one does exist. This one does not. Okay, so again, this is more about the factoring than the trig part, but that's how we would solve. Okay, so let's do a couple more examples. I'm going to do 2 more examples. If you think you want to try them on your own, go ahead and pause it and then hit play and see if you get what you started or get what I get. And then, but either way, I'm going to pause the last 2 and let you try those. Okay, so first thing, I'm multiplying 3 times 10. So this is now a positive 30. And then into my parentheses, I'm putting a 3x in both of the first spots. So now I want a factor pair of 30 that adds up to 11. Well, it could be 1 and 10, which adds up to 11, 2 and 15, and 3 and, oh, I'm sorry, not 1 and 10, 1 and 30, 2 and 15, 3 and 10, or 5 and 6. 5 and 6 is the one that adds up to an 11. So I'm going to put a 5 and a 6. Again, doesn't matter which one goes in which spot. Okay, 3x plus 5 stays where it is. Can't take anything out, but here that extra 3 can come out that we put in, and so I have an x plus 2 here. So this is my factored form. Okay, and then again, if it was equal to 0, then I would I would set each factor equal to 0 and solve for x from there. Okay, next example, 6 times 2 becomes positive 12. So into my first terms, I'm putting a 6x on both. Okay, so now I'm looking for a factor pair of 12 that adds up to -7. Now, if my product is positive and my sum is negative, that means both of my numbers, both of my factors are going to be negative, okay? So between 1 and 12, 2 and 6, 3 and 4, really I'm looking at negatives on all of these, and it's going to be -3 and 4 that add up to -7. So -3, -4, again, doesn't matter which one goes in which spot. Okay, now if you remember, we multiplied by an extra 6, meaning we need to divide by 6. That could be dividing one of the binomials by 6, or it could be dividing one of them by 3 and one of them by 2. And if I look for common factors, that's what I have here. These two are both divisible by 3, so if I divide by 3, I have 2x minus 1 left. And here, if I divide by 2, I have 3x minus 2 left. So I still took out 3 times 2. I still took out a 3 and a 2, which has a product of 6. I'm not adding. It's not 5. I divided by 3 and divided by 2, so I divided by 6. Okay? But here I had to take something out of both instead of just one. It's not likely that you will see this in any of like quiz or test problems, but it is possible, and I'm just showing that the factoring still works. Okay? At this point, I think it'd be a good idea for you to pause and try these on your own and then resume and see if you get the same thing I do. Okay, so 4 times 15, negative 60. Putting a 4x in both of the first spots. Okay, and then factor pair. I'm going to move this one over a little bit. Okay, so factor pair of negative 60 that adds up to negative 4. So I'm going to have 2 different signs. So my options are 1 and 60, 2 and 30, 3 and 10, 4 and 15, 5 and 12, 6 and, okay, lots of options there. 6 and 10, if my 10 is negative, it's going to add up to negative 4. So positive 6, negative 10, again, doesn't matter which is which. Now we should be dividing by 4 either from one of them or 2 and 2. Okay, so I got a common factor of 2 here. So 2x plus 3 is left when I divide by 2. And then here when I divide by 2, I have 2x minus 5 left. So there's my factored form. Okay, and then one more. 10 times 1, this is now a positive 10. Positive product and a negative sum means that both of my terms are negative. My factor pairs are 1 and 10 or 2 and 5. 2 and 5 is the one that's going to add up to the negative 7. Oh, forgot the 10x. Okay, so 10x in both spots, minus 2, minus 5. Greatest common factor here is 2, so when I take that out, I have 5x minus 1. Greatest common factor here is 5. When I take that out, I have 2x minus 1. So again, I divided by 2 and I divided by 5, which is the same as dividing by that extra 10. And there's my factored form.